Hi. Welcome back to the second episode of my process video. I tried out different mic because I noticed you couldn't pick up a lot of my mumbling in the last episode, so I got this little laugh clip mic here, and I hope it's better now. Anyway, if you don't care about my whole introduction thingy, I'll make a timestamp so you can just skip to the start of the process video, episode 2. But yeah, we will continue on it and see where it goes. I just want to save for out, so I don't want to keep it like a loose process video, but sometimes I just can't figure out something for half an hour, and you don't want to watch me just trying out 5 different things. Maybe if you do, let me know. But so sometimes I explain something and about a basic concept, but then I cut it out without noticing it, and I imagine it might be confusing for beginners. If I then, after my third attempt, I'm like impatient and just do it fast and don't explain it well, and you're like, what the hell is he doing? So if you notice I don't explain something well, or you have questions, you can always ask in the comments, and I will try to answer. I won't try, I will answer. There's like 2 comments, not much work. Okay, but yeah, that's it for the introduction, and let's get to it. Let's see what we're gonna do today. So yeah, last time we left off, we made this little spline. You can see this will be the input we would have in Unreal later. We can just draw a spline, and it will then conform to this spline. So maybe let's try to close it, because I don't like this gap. You don't want to have a castle with a huge gap. So let's close it. Yeah, lower the volume of my ambient background music. Cool. Well, let's see. Maybe we can maybe there's an option to close it here in the curve. That would be very handy. There's not. Operators, delete select. Segment between select. Maybe that one. Why does that not work? Delete segment. Well, that's we're off to a good start here. That's how it is. That's a lot of this stuff is me relearning Houdini and just messing around with so many different parameters. And I'm gonna cut out a lot of it, so you don't have to sit through it. Please work. Oh my god, I'm an idiot. Okay. So in general, when you have any node here which requires you to select stuff in the viewport, you want to be on this handle here. This is the action mode for whatever node you have selected in a way. So I was trying to select them with the normal poly select tool, right? But there's a dead, they made their own. Yeah, you get what I mean, right? All right. Control. Okay, and now add segment. Cool. Voila, our wall is closed. Where are the normals? And boom, let's turn off those numbers. Yeah. So I was thinking, my previous tool I made, the one I'm basing this on off, had not much detail to it. It was, I guess, more meant as a base mesh. People can then slap textures on or like add more detail themselves. But I think it would be fun to explore how to create detail in Houdini. For example, let's open our reference here. For example, the bricks of a wall, like how can you create it in Houdini, or the roof tiles of a roof. And maybe I thought we can also turn it into a game-friendly version where I wouldn't have like every single tile be its own geometry, but have it a bit more stylized, where I have just a few, well, not stylized necessarily, but just a few meshes which breaks up the flatness of the wall. But yeah, okay, we'll see what we do, but definitely want to mess with more detail, because that's the fun stuff, some of the fun stuff. Reference, which one are we looking at? This one. Yeah, so we can try to make some breaks. Yeah, I'm kind of looking at this reference now mostly while creating it. Maybe we'll look at some others. That's what I'm talking about, where we have some single sticking out rocks, like here, to break up the flatness of the wall. Okay. So I was looking at the windows and door and everything. I was wondering how we can do that. So maybe now we'll show you a bit how to work with Booleans. So we can make, find the places for some simple windows. I was thinking we can try to base the position of those windows based on our spline. So maybe we have windows just scattered along our spline, and we go from there. So let's try that. So in order to scatter something along a spline, you want to know where you want to scatter it. So let's say like one window on every segment. That means we would need 1 point on every segment. In order to add points to like edges or like lines, splines, whatever, we can use the, good question, what was it called? Dude, this cable is too short. My mic setup is fucking terrible. It's disgusting. You don't wanna see it. I gotta clean this up. But yeah, what was it? It was called sample. So we can plug this in. Boom, yeah. And you can see we have a lot of points. And then we can of course control. So you can control it either by length, so the length between each point, I believe that means. Or you can also control it per maximum segments. But you gotta turn off the length. Oh, you don't have to, but okay, it's changing the shape. Maybe that's fine. Yeah, that's fine for us. That's just for the windows. So let's say we want 2 windows between every segment. Let's start with that. So that means we need 2 points in between. That means we go 2. Oh, 2. Okay, we don't have to be that accurate. It's fine. This is, for example, one value we can expose later. Say, oh, you want a lot of windows, slide it up. You want less windows, just slide it down. So that's the beauty of those procedural assets. Cool. Then let's make, just in case people are not familiar with Booleans, it's just cutting out shapes from other shapes. Let's make the shape we want to cut out. Let's just add a box. Of course, you can also name your nodes and call it cutout and all of that, but I cannot be bothered. Cool. Yeah, let's just leave that size for now, I guess. No, that's a bit too big, maybe. Let's make it a bit smaller. Cool. So now we can take those points And then a very useful note is copy to points. Copy to points. You can see the whole Blender procedural. I haven't looked much into the Blender procedural asset stuff, but they utilize this idea as well, that you can put points at positions and then place objects at those points and stuff. But I don't know, something to look into. So now what we did is we scattered our this. Now we gotta switch that around. I want the box on the splines. There we go. So okay, now you can see it's a bit rotated weirdly, like you can see they rotate like so. But we want them obviously to be straight on the wall. So this is always a bit tricky. Usually a good start is to create a polyframe. Yes, a polyframe, which lets you control a bit the normals of the points. So in order to visualize the normals, you can turn on this, and you can see the point downwards. But we also can, oh god, that's a whole nother topic. Should dive into this now. It's gonna get boring. Let's skip that for now. You gotta know, there's points have different information. You can see it down here. Maybe my video is on top of it, but you got the tangent, right? So you got the normal, that's like a vector pointing in one direction, and then you have a tangent, which is like a vector pointing as the tangent going off of the normal. So you got a bunch of directions you can mess with. Then you're getting a third one as well. But yeah, in general, first thing I try when I want to fix this, I create a polyframe node and I switch around those tangent U with up here and here N, and that did nothing. I just want we Google Houdini, help me please. Houdini aligning normal to edge. Does that work? In this case we want underscore px. Oh my god, I'm so lost. Yeah, I just want you know how to declare shit bullshit.
1 hour later.
We did it, guys. Guys, we did it. It worked. I'm so happy. I can code. See, I'm a programmer now. I am programmer. What the fuck is going on? I am the programmer. Easy like that. It takes an hour looking up tutorials and like a bunch of what's that called? Documentation pages. This is ridiculous. There is an easy way to do this, but we learned something. You learned something. Not yet, but I'll explain it properly in a moment. Okay, summary. What happened here? So we have our fucked up normals, or not our normals we don't want, and we use a bit of math to find out the direction. So the normal points from one point to the next point. Basically what we do is we subtract the position of this point with the position of the next point. And this gives us the direction. My math is also rusty, so I just know this works, but I should probably calculate through it to actually understand why this works. Yeah, I probably should do a test. Whatever, it works. Trust me. So this is the code. You can see I used two inputs in here. This is because I sorted the points. So you can see by default our points. I'm trying to find the 0. There it is. There's here, and then I offsetted them so I can address the next point. So I used the sort node and set it to shift and offset by 1. So now you can see I go between them. And now here's a 1. Before there was a 0 here. I put 1 in the first input, sort in the second input. Right. And then what you can do, so we create a variable like we showed before. It's a vector variable where we want to save the position, the point position of our first input. And we say equals. And then we can use this expression to address our first input. So up input 0, and then up input 1 will be our second input. And then we write underscore p. So whatever you read here is the attribute you address. So you don't write at p like you would normally because you already wrote it here. I guess that's just how it works. So in this case we get a position. If you write cd, for example, you get the color attribute. So yeah, whatever attribute exists on your mesh. Yes, and then you save them into the variables. This was just a test, and we don't need this. And then we set our normal attribute. Like I said before, we have to use the set function. And here we do the math. So as said, what we did, we subtract first 1 point from the next point. This gives us the direction. So this is all we did. Our first position. So we said, P1 is this variable where we save the position, and then we want to address x. We don't want, else it would take the whole vector, and that doesn't work because this is our x position, y position, z position. So that's why we write .x to address only our x position, or the first position of the vector, I guess. Probably not using right terminology for this, but hey, it is what it is. Yeah, so use p2.x, so we subtract the x position of our second point, right? Second output. And we do the same for y, and we do the same for z. And as you can see, indeed, our normals look right now. Before, after, we are to see. Copy the points. For, after. I have to go to bed. Okay, let's do it quick. Let's Boolean. Let's make actual holes in our walls. Holes in our walls. Let's reduce it. Reduce the amount a bit. Those might be problematic. We'll deal with that. Shit, it still doesn't work though. So we want the windows in between. So we should somehow manage to always keep our corners, because now our corners disappear if we have a low enough poly count. So can we do that somehow? For example, by polygon edge. Nice. Okay, there we go. So now if you enable this, our corners will always stay. And If you say 2, you will have 1 point in between. This is perfect for what we want here. Now we can exclude the corner edges if we want. Later. Yeah, let's do it later. Let's just Boolean now. Let's have some fun. Let's have some good old laugh. 2 windows. Boolean. Boolean. Then we have our wall. By the way, Booleans are expensive operations, as you might think. So they make your graph quite a bit slower, but it's, just that you know. So if you find a way to do something without a Boolean, usually that will make your graph faster. How to optimize your graph, we'll go over that eventually. Where's our wall? Our wall is fucked. I unfucked our wall. Amazing. So we Boolean this out of this. Let's try that. Okay, now we're doing it the opposite way. That's pretty cool, though. So we Boolean this out of this. Cool. Cool. I don't want to see points. Get the fucking points out of here. Why do I see points? Distracting me. I don't want to see points. Better. Not good. Yes. So now we can. So if I toggle on this here, I can see the wireframe of this node. I can move this. Put a transform on our, on those transform node. So we can move it up and down. So we can see, just see some stuff change, Now, toggle this off. Itchy eyes. Okay. Can move it. Okay, we need to make our cubes a bit longer because now it's acting weird. Yeah, you wanted to do is to go through your whole mesh. But now our back wall disappears. That's not cool. So why does this happen? Do we have open mesh? Yeah. Oat milk is so much better than real milk, by the way. Get into it.
The next day.
Oh, so I found out why our walls disappear and why our swept mesh is weird. Weird in the sense you can see looks like the normals are flipped or something on the places where we fused it together. So even though we checked that we fused it properly, it's one vertex, we checked it, it's still weird. Well, I found out what we can use is this polypath node, which just takes edges and makes it into one continuous curve mesh, I think. Something like this. But it works. So now that we connected this polypath, you can see no more weird faces. That's without. With faces are fixed. So now let's see if our Boolean also is. Yeah, our inner walls are good now. So okay, now we still have the issue of we don't want those corner windows, they're weird. And let's only keep the windows for the faces. That's how a castle looks. Yeah, so let's have a look. How do we do this? So the way we can select our corner points is by using a measure sub. this allows us to measure different things for edges and points and so on. So if we plug this in here, we want to measure a point. So we try to somehow find out the curvature or the angle of this. So we have a curvature here, and then we set this to Gaussian. And yes, so now you can see now our attributes, we get like a curvature here. And all the things with curvature are above 0, usually. So let's see if they work. So we can create a group. And then, so point. And then you remember, in here we can, type things and then it will select things. But we can also type in attributes. So we want to address our curvature attribute. So we write curvature. And then we want to say select everything which has a curvature higher than 0. Maybe 0.1. Oh. You can write spaces in here. Yeah, that's it. No spaces in here. Yeah, you can see it works. So if I go higher, for example, 0.1, okay, it's selected, 0.5, yeah, you can see it doesn't select this corner anymore because the angle is too shallow. Shallow, is that the right word? Whatever. So yeah, that's a way you can control the steepness of your angle you want to have selected. So let's keep it on 0.001 or so. And now we have all the corners selected. Hooray. Cool. And now we can call this group underscore corners. We wanna have this in here, of course. Let's organize our nodes a bit. No, like this. Like okay. What is this? We don't need this. Okay. Coolio. So now that we have a group with our points, we just need to blast them. Group corner. Did it work? Must have worked. Okay, no. So now we have delete non-selected. Yeah, there we go. Now I can see we lost all our points. If we increase our segments, you can see we have no corners anymore. Just what we wanted. Meaning our windows are now only in here. Jesus Christ. Yeah, okay. So now we have our spline. Maybe we can use the same one? Probably. I don't see a reason why we can't use the same one. Or maybe we should use the same one, actually. What's the reason for that? Okay, what I did, I just turned off a bunch of stuff like those. I just left up axis, so our sweep knows where up and down is, I guess. And then we're not messing with them normals. It's a bit weird that if we have one long wall and one long wall and one short one, that we have the same amount of windows. So maybe we can just adjust it actually quite easily by toggling this in our resample node. Yeah, instead of going by segments, we can go by maximum segment length, I believe. Yeah, maybe. Yeah, no, it should be more even. Yeah, now it's more even. Now here we have 4 windows, or here we have 2. I think that's better. Make it bigger, maybe. Control click, you can add a vertex in here. Cool. Let's don't forget, we can also adjust our height. And our depth. Cool. Maybe we can adjust the normals a bit. Yeah, we can of course also mess with our spline we created if you wanted to. Make all kinds of funky shapes. Ideally you want to look at reference, you know, if you create a castle. But now I'm just messing around with it. Down here we made the little transform before. We can adjust our windows. You can see it's pooling it all pretty smoothly. You can adjust our window size, of course. Maybe we don't want a window. Now you want to break up the repetition of our windows a little bit. So we could do that by going to our points. Where points? And select a bunch of random points and delete them. So we can just add a group. We can call it group random. And there is this keep by random chance. It's not working. Oh, okay. We gotta select points. Yeah, now I can see it selects our random points. We can say percentage. Maybe we only want to delete 15%. So now we want to blast those random selected vertices. So we create a blast node, we select our group, random, and they should be gone. Indeed, they are gone. You can see after, before, after, after. Then we can mess with the seed a bit so it looks good. Looks more interesting now. So look at our reference. Where are we? Now our windows are pretty simple. Maybe we do want to add extra windows to it. There's no limits to how detailed you want to go into this. Maybe we can add different rows of windows. You can see it's quite random here. So you have like those vertical ones. These here seem to be in a grid kind of. You have the single ones, you have double ones, you have, oh, that's a door, I guess. Yeah, that's a door. But yeah, I would say let's leave it at that for the Windows and move on to something else so we don't get bored. Maybe we can add those zigzag things. How are they called? Palista, was it? I learned that name, but I forgot what it was called. Powerpad? I don't know. Oh well. But this will be for our next video. So if you like this video, like and subscribe, and let me know if you have any feedback or if you want to know something. Thanks for watching, and peace.